Today we will deduce Kepler laws from the particle moving under inverse square force. We know that when a particle is moving under the central force or inverse square force, then it will follow conic path, and the motion of the planets around the sun is also follow conic path. Therefore, we can deduce these Kepler laws or the motion of planets around the sun by using the concept of motion of the particle under inverse square force. So, one article is deduction of Kepler's laws of planetary motion from the motion of a body under central force or inverse square force. Central or inverse square force. So, we will deduce or derive Kepler laws by the concept of motion of the particle under inverse square force. Now, we know that there are three laws given by Kepler for planetary motion. What is first law? First law is called law of orbits, or we know that when a planet moving around the sun, it always follow elliptical path. So, E is less than 1. We know that eccentricity of the particle is less than 1. This is a condition for elliptical motion or elliptical path. So, we have to prove E is less than 1. And second law is the law of area. Law of area. So, what is second law? The line joining between the planet and the sun always sweep equal area in equal interval of time, or we can say that the area traveled by line joining between sun and planet is always constant. So, this is simple form, that is we have written this law in mathematical form. So, this is mathematical form first, second, and third one. Third law is also, it is basically mathematical law, that is T square proportional to A cube. The square of time period of the planet around the sun is directly proportional to cube of the semi major axis. So, what are major axes, what are time period, what is area? So, we will discuss in detail and prove these three laws by using the concept of motion of the particle under inverse square force. So, first of all, I will prove the first law, that is E is less than 1. So, I will prove E is less than 1. So, we know that in case of planets there is sun, it is an ellipse and there are two focus point, that is foci, and sun is lying at the one of the focus. So, sun is here and planet is revolving in a fixed orbit, that is elliptical orbit. So, the path followed by the planet around the sun is always elliptical. This is first law, elliptical path or elliptical orbit. So, we have to prove how this path is elliptical, this path is elliptical. So, we know that the formula for eccentricity is 1 plus 2EL square over mu k square. We have already proved it in the previous article, and we know that the planet and the sun, it is bounded system because both are bounded with each other. So, for bounded system, energy of the bounded system is always negative. So, you have to learn that this energy is always negative for boundary system. If E is negative, it means this E is negative, and this whole term become negative because negative into all positive terms, that is negative. So 1 minus something, that is less than 1. So E will become less than 1. So this is first law. So we have proved in a single line, that is for the bounded system the condition is E is negative, and we have applied this condition in eccentricity, so eccentricity become less than 1. So which proves that the path followed by the planet around the sun is always elliptical, the first one. Now second, what is second law? Law of area or areal velocity. So what is that? The second law, basically the line joining, this line, the line joining between sun and the planet, this line sweeps equal area in equal interval of time. Let there are two interval from P to P dash, and second interval is from this to this, that is Q to Q dash. The time taken by the planet from point P to P dash is, let it be T, or the time taken from Q to Q dash is also T. So it will cover more this path, and it will cover less path. It means the motion of the planet near the sun is faster. So this one, the concept is, but area in both cases is always constant. So in the first case the length is greater and width is small. In the second case length is smaller and width is large, but the area, the thing which is constant, that is area. So this is second law. The second law means the rate of change of area is always constant, or the line joining between sun and planet sweeps equal area in equal interval of time. So area is always constant. The second law. So we will prove this law by using the concept of area. We know that area, small area, let it be small area, let this is SPP dash, this one, this area. We will consider it as a triangle. DA is equal to, we know that area of triangle is half into length into breadth, or base into height. So base is this, let it be R, radius. It is less than R, but if we know that the distance between S and P is very large, therefore SP and SP dash both are nearly equal. So let it be both are R. So length into breadth. What is breadth? So this breadth is R d theta in polar system. Let this angle is theta and this arc become R d theta. So area of triangle is a triangle. SPP dash is half length into breadth or base into height, and it will become half R into R square into d theta. This is dA, and dividing both sides by dt, we will get half into R square into d theta by dt. And what is this? This one is theta dot. It will half R square into theta dot. So you know that theta dot is L square by mu R square. This half into R square into L over mu R square. Sorry, this is value of theta dot, which we have already studied. So this R square is cancelled with R square, and the final, the term, remaining term is d A upon d theta become L upon 2 mu. L upon 2 mu, and L is constant, 2 is constant, and mu is also constant. So all these terms are constant, and hence you will get finally the constant answer. So this is the second law, that is the areal velocity. The rate of change of area with time is called areal velocity, as we have already know that dx by dt is velocity, simple velocity, but dA by dt is called areal velocity. So this is also called areal velocity, area, which is linked with area. So areal velocity is always constant. So this is second law. Now we will prove the third law. What is third law? Third law is purely mathematical law, that is t square is proportional to a cube. Now what is the meaning of, what is the terms t and a? What is t? T is a time period. Time period means it is the time taken by the planet to complete one revolution or one rotation. The planet moving from, starting from P, and again it will reach at P. The time taken for the whole path is capital T. So this one is time. And what is A? We know that in case of ellipse there are two types of axes. This is called major axis and it is called minor axis. These are two axes. As we know, in case of circle, both major and minor are equal, but in case of this ellipse, the axes are different. This is major, that is large, and minor means small axis. So total major axis is 2a. So this is 2a, and this one is, it is 2b. Total minor axis, and half of the major axis is a. This is a, is also a. So this is a, and it is b and b. So these are two parameters a and b, which are connected with the ellipse. So according to third law, t square is proportional to cube of a. A means semi-major axis. Semi means half. So half major axis, cube, and square of t. This is third law. We will prove this third law by using the concept of force under inverse curve law. So we will start from t. You know that. What is t? So you have already read that t is the distance over velocity. Simple. Or in case of circle, this distance become circumference 2 pi r over velocity, and in case of area velocity, it is area over aerial velocity. So this is the formula for time period, that is area over aerial velocity. So what is area of ellipse? Area of ellipse is pi ab. As we know, area of circle is pi r square, but in case of ellipse there are a and b are different, radius are not constant, so pi into like as r into r, that is a and b, pi ab over area velocity dA upon dt. This is. Now we have to prove the formula for time in terms of a. We require a, so a is here, and the remaining terms will also be converted into a. So putting the values of formula which we have already known, that is dA by dt is L over 2 mu. I have already proved in second law. So this is pi AB over L over 2 mu. So it will become 2 pi mu AB over L t. So 2 is constant, pi is constant, mu is constant, L angular momentum is also constant, but A and B are variables. So A, we will require A, but B is not required. So we will convert this B in terms of A by using the formula of latus rectum. So now I will convert this B into A. So what is the formula? Since latus rectum is equal to B square by A. This is the formula from the ellipse. L is equal to B square by A, and also L is equal to L square by mu k. L square by mu k. We have already proved in the previous article. This L. So both are the values of L. So compare these values of L. We will get, on comparing, B square by A is equal to L square by mu k. This is comparing means both are the values of L, therefore the values are equal. So from here you can find value of B. So what is B? So B square become L square A over mu k. This one. And B is L square A over mu K under root. This B, sorry. So I will write this B as under root of L square A over mu K, or L is taking common from the under root square root, it is A over mu K. So this is value for B. So putting this value B in this equation of time equation B. So we will get finally T is equal to 2 pi mu A into B. B means L under root of A over mu K over L. L will cancel out and the remaining part is 2 pi mu over mu K square root A into A square root A raised to power 3 by 2. Okay. This is T, or this mu K may be cancelled out with 2 into pi, into mu, that is mu square root and mu, it will cancel mu by K under root and A raised to power 3. So we are only concerned with the value of A and others are constant. So T is any constant into A power 3 by 2. So taking square on both sides, that is T square, square of this T square and square of this 2 pi mu upon K under root power 2, and this will become A cube, because A 3 by 2 raised to power 2, 2 will cancel out and finally we will get A cube. So all these are constants. So we may write this constant and equal to as proportionality. It is A cube, where this is constant. So this is third law. So in this way we have proved all three Kepler laws by using the concept of motion of body under inverse square force. Thank you very much.